Hello everyone, good afternoon. Dear authors and invited guests, welcome to Technical Session 10A. Myself Adesh Bazare, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastic LLP, it is my great pleasure to welcome you to the 9th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2025, Bangkok, Thailand. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held on 4th April 2025 in Bangkok, Thailand, and the virtual event is being held through Zoom on 5th and 6th of April 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for question and answers. On 9 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in chat box. Before we start the session, I would like to introduce you all to the chair for this session, Dr. Priyadarshini J. Ma'am is a professor at Vellore Institute of Technology, Chennai, India, specializing in machine learning, image processing, deep learning, and natural language processing. Her research focuses on artificial intelligence, large language models, and medical image processing. With extensive academic and research experience, she is dedicated to advancing AI-driven innovations in healthcare and computational intelligence. Ma'am, may I now invite you to share your opening remarks with us?
Yeah. Hi, good afternoon all. And thank you, Adesh. So this is Priyadashni and I'm delighted to be session chair for this conference. Let us see what the people are about to present.
Sure, ma'am.
Yeah,
Thank
thank
you.
you.
Yes. Now, I would like to start with papers. So, we will begin with A.M. Hafiz, who will present his paper on a novel technique for security augmentation of cryptographic algorithms. Mr. Hafiz, are you in the session? We'll move towards our next presentation. Our next presentation is Mohammad Robel Mia, who will present his paper on an approach for finding political views using LDA from newspaper comments, the Bangladesh context. Mr. Robel, are you in the session?
Yes, sir.
So, are you ready to present your presentation?
Yes, I can share.
Okay, sir.
Thank you. Hello, everyone. Good evening. Am I audible?
Yes, sir, you're audible and your screen is visible. You may continue.
Thank you. First of all, thanks to our session chair and all the presenter, all the people who are joined in the session. And I am MD Mohammad Rubel Mia. Our paper title, and approach for finding a political view using LDA algorithm from newspaper comment as a perspective of Bangladesh context. Our paper ID 28. So here is the author. Just a minute. So here is the author of our paper. Me, MD Mohammad Rubel Mia, Nasrin Jahan, Bimal Chandra Das, Raghul Rahan Chaudhary, and I am the presenter. And from our paper, all the author, I will present our from our paper. So here is the presentation outline. So you can see the first of all I will introduce. I will explain a few introduction about our paper. Then background and motivation, literature review, research methodology, experimental procedure, and finally conclusion and future work. So first of all, I will start about the presentation, about the introductory part. So since the paper title is political view finding from newspaper comment, so you can see you all of the you know that the rise of social media and online newspaper comments has provided a platform for political discussion as well as others discussion also. So from this perspective, we chose the newspaper comments for our for the implementation of our paper. So we can see identically political view from textual data is challenging. So for the perspective, we chose the paper and our research here we applies the LD algorithm, that means latent descent allocation, to analyze the newspaper comments and extract the political segmented. So here I explained that the our accuracy was 93.0307%. So here is the overview and process to finding the political view. So here you can see the two political view or two picture. So in top left, so you can see here first of all we pick up political comments from newspaper, and after that we have pre-processed the data by using texting, tokenization, then part of his speech and social media. And after that, we have used feature extract, and finally we got the application area. So here also you can see the another picture or another process to finding political view. So here you can also see the how we can implement our whole process. So here first of all we pick news as an input, then our system implement the whole process, topic finding, and here we use LDA. And after that, finally, we got the support report. That means we use here three types of outcome or result, or three types of parties. That means Awami League, PMP, and Jatiyo Party. And based on that, we can finally got the comments as in three parts: positive, negative, and last of all, neutral. So here you can see the motivation and outcome. So before we studying our paper, we can analyze or research a lot of the earlier former research papers. So we can see most of the process are traditional way and traditional survey, or time consuming, or expensive. So and as well as which all of the paper or all of the work are not automated way. So from this perspective, we automate the analysis of newspaper comment that can provide a insight in political point of view. So where our aims to develop a model that categorize political views from textual data. So here you can see at a glance literature review. So if I explain in a bullet point, so we can see most of the researcher work only documents, or few of the researcher work only for word, few of the researcher work for sentence, or few of the researcher work for article. So we can see the none of the researcher have worked for newspaper comment. That means there is no existing systems to define a political view. So from this perspective, we are encouraged to develop or implement our solution. So and we realize that this will help as a to help political leader, as well as to it will helpful to implement as a system. So here next you can see the research methodology, where which we will implement, which we will follow to implement our system or paper. So here, first of all, we pick an unstructured newspaper news from different kinds of portal, and after that we cleaning and shaping the data, and after that we document stamp, we use the document stamp matrix, and after that finally we use the LD algorithm uh, to implement the system, and based on the LD algorithm, then we got the our expected outcome, the where we got the probabilities and classification. For probabilities, we use term topic probabilities and document terms probabilities. So here is the bullet points of our research methodology. That means data collection, pre-processing, data modeling, and categorizing, and finally evaluation, as well as the measuring accuracy or effectiveness. So here is the experimental evaluation. So to explain the more experimental evaluation, first of all, I will enlisted here the key points. All of the
Excuse me, sir.
listeners.
So
Sorry.
sorry to interrupt you, but you have 2 minutes of time to conclude your presentation.
Okay, sure, sir. So here we use data from data sourcing, newspaper analyze, and technology we use Python and LDA. And here is the stepwise model training process. So here is the outcome. Here you can see the confusion matrix, where we use three types of categories: positive, negative, and neutral. So here is the outcome. Here is, you can see, also you can see the binary confusion matrix based on our result. So here you can see the SBM, that means outcome accuracy of our paper. So here you can see the 93.07% is the our accuracy, average accuracy, and here is the value or rest of the result. So here you can see the individual all types of feedback or result. So here you can see positive result is the highest accuracy, 94.06, and rather than negative and neutral. So here you can see the sample input and outcome. So here you can see the exact outcome. So where we pick newspaper comment, and here you can see the exact outcome. So here is another example. So here is a pie chart in of the confusion matrix. And here you can see the survey, where we show the date, time, newspaper, title, and comments, where we based on the survey or based on the data, then we implement our system. And here you can see the accuracy you from rest of the other paper or other researcher. So here you can see our paper accuracy is 93.07%, which is the better than in rest of the paper. So here you can see the conclusion and future work. So in a short way, I can see that I can say that the LDA effectively identifies political topics from newspaper and contributes to the automation political segment analysis. And our future target is to increase the data set for better accuracy, and incorporating the deep learning for improvement analysis. And last of all, we try to will in future we'll try explore the multilingual analysis for border border perspective. So that's all from our paper, and thank you all for your patience or for your attention.
Okay. Thank you, Mr. Robel. Actually, it's a nice topic. I just have one query, like why have you not compared with any other models? You have concentrated only on particular LDLO.
Madam, we just compare rest of the paper, but in future our target is to also will compare or also different types of algorithm also. So it's our future target. So in this paper, we will not compare with any other different types of algorithm.
Okay, but unless you compare, you will not know that your method is the best. Okay, so at least basic ML or deep learning algorithms you can compare, and in future you can go with large LLM models.
Sure, madam.
Okay, okay, thank you.
Thank you, madam, for your feedback.
Thank you, sir. Now we'll move towards our next presentation. Our next presenter is Neha Junagare, who will present a paper on analyzing existing cryptographic protocols, quantum key distribution, and post-quantum cryptography to enhance security in the quantum computing world.
Yes, sir. I'll quickly start sharing my screen.
Yes.
Okay. Good afternoon, everyone.
Good afternoon, ma'am.
So good afternoon. My topic for today is analyzing existing cryptographic protocols, quantum key distribution, and post-quantum cryptography to enhance security in the quantum computing world. So this paper has been written by myself, Dr. Sheetal Bhandari, Dr. Rachna Y. Patil. Both of them were unable to join this session for personal reasons today. We'll quickly take a look at the outline that we have. We'll begin with the introduction. How is quantum algorithm and cryptographic getting impacted? Quantum-enabled vector attacks, other threats in regards to classical protocols, apart from the key ones that we saw in the previous slide. Role of QKD, post-quantum cryptography, comparative security evaluation. How are we analyzing if it is getting impacted? Recommendations and future direction. And after that, we'll go to the conclusion and referencing. Next, let's start with the introduction. I'll start with a brief introduction as to how quantum computing is presenting challenges in this. Just a minute. Okay. How quantum computing is presenting challenges at this moment. And quantum computing is challenging the classical cryptography. Two examples that I could come up with here was Shor's algorithms and Groove's algorithm, which are threatening RSA, ECC, and DH. Right now, we focused on analyzing how these threats evaluate the protocols mentioned above and explore solutions like QKD and PQC. That is the overall summary of this paper. So let's begin with Shor's algorithm. How is it getting impacted, and how is it impacting getting impacted by Groove's algorithm as well? So Shor's algorithm efficiently factors large numbers and solves discrete logarithmic problems in polynomial times. This makes a direct threat to RSA and ECC both at the same time, whose security lies completely on difficulty of solving these problems. For RSA, we're very well aware that it is based on the multiplication of large prime numbers, which current systems cannot are not able to solve. It takes millions of years with current computational power, but with Shor's algorithm that can be done, and with the help of quantum computing, that a lot of tests have been done in which people have decoded those systems, the base of cryptography, in 10 minutes. Next is Groover's algorithm, which is reducing the complexity of brute force attacks on symmetrical ciphers. For example, 128-bit AES key with an effort of 2 raised to 64 operations can be successfully decoded. What are the implications? The implications look quite serious. Even the trusted protocols like TLS, HTTPS, PKI have become vulnerable to these implications. There are a lot of tests that are being done by large companies in understanding how that is getting impacted. So while doing this, the first approach that we saw was, can we make some changes in the existing system which will help the system be quantum safe or be secure? So first thing would be having post-quantum cryptography, and second one was QKD, which is again a concept in quantum physics itself. Can we leverage that system and use as a countermeasure to the threat? So, what are the quantum-enabled attack vectors that we have? Quantum computing just doesn't threat algorithm. It is opening the doors to enhance attacks as well. First one would be man-in-the-middle attack. We all know that with the real-time situation, man-in-the-middle attack is real and is impacting the current system. But with quantum decryption coming in picture, attackers can intercept and alter communications more effectively as compared to the current system. So this might get impacted or enhanced when it comes to quantum computing. Second would be replay attacks. In this particular one, legitimate message sequences are reused. QKD helps by unique keys in every session. So in replay attacks, the same set of messages are being sent, but with the use of QKD, we can generate unique keys in every session that is there. And it need not be manually generated. It's by design how QKD works. The third one would be eavesdropping attack. With quantum technology, attackers might try to tap conversations that are being sent from one location to other. But with the use of QKD and its principles of quantum mechanics, like no cloning theorem, measurement disturbance, which understands these attacks, detects them, and tries to stop them. So these three attacks can be reduced with the use of QKD, which get enhanced while quantum computing come into the picture. Next, what are the other quantum threats to classical protocols? Beyond direct cryptographic attack, quantum advancement includes subtle threats like the smaller ones, denial of service, which is
Neha,
also, yes, ma'am.
sorry to interrupt. Do you have any work that you have done, or it is only about this kind of presentation?
Ma'am, this is more on the analysis side of it. Right now, I am working on my PhD, and this is some pre-work that I had done to start my simulation. So this is more on understanding what is the current situation and what is the main pain point that we have, and how can we start working towards it. So there
Because
are
it's only 10 minutes presentation, you're already lagging behind. That's why. So you can directly shift to the work what you have done.
Ma'am, in this paper, when I submitted this paper, just came up with the analysis bit of it.
Okay.
So more of it, this is a comparison. So there are other slides as well. Looking at the time, maybe I can just quickly go to the final output that I could come up with. So these are the type of attacks that we had. What are the affected protocols? What is it that QKD can help us? So I was able to analyze these 10 attacks specifically and come up with that RSA needs the most security, and how can QKD further enhance it.
Okay. But see, even though it is a network related one, okay, is it going to be applicable for a homogeneous network or heterogeneous network? You further on, you're going to work on with a homogeneous network or heterogeneous network?
Ma'am, right now I'm focusing on RSA itself. I'm not completely aware. I didn't explore that bit. It is a part of the objectives that I have for my PhD.
Yes, my dear, RSA is just an algorithm, but where you're going to apply also matters. And quantum computing, mainly they go on with IoT devices. Right
Yeah.
now, the trend is with IoT devices. So if you can be more specific about the application which you're going to take, your studies also will be varying. Okay, because right now you have taken a generalized concept, and all of us know that RSA is very good for the network security side. Fine. So, uh, because on you are on a learning stage, I can accept, but still, if you are really working on this, then you really need to concentrate more.
Yes, ma'am. I'll definitely go back and take a look at the homogeneous and heterogeneous side of it.
Okay.
Recently, I've just focusing on merging RSA with BB84, and I managed to get some result, but I'm still working on that. But I'll definitely take that feedback, ma'am.
Okay.
Yeah. So I'll just summarize the presentation then.
Yes,
What
yes.
what was the recommendation from the study that we did? We need to come up with a hybrid cryptographic protocol, which is a combination of QKD plus PQC. And what does what are the opportunities in research side would be hardware optimization in QKD, because that's one of the biggest challenges that we have right now, and PKU algorithm standardization, because that is available in very limited options, plus a lot of aspects like noise and other things needs to be taken into consideration because it's very noise sensitive. Third, integration into protocols like TLS, VPN, HTTPS. So right now I was just focusing on the algorithm bit of it. How can we merge it and how can we use it? But the next step would be going into protocols directly. And if we can merge them into protocols, that will provide a better security options. So the focus would be an adaptive method that can come and have a scalable secured solution. Existing protocols that we have, RSA, ECC, and DH, are not secure in quantum age. QKD offers quantum level protection, PQC offers practical resilience, and a combined approach ensures long-term secure communication that we have. Yeah. Ma'am, any questions apart from that?
As I told you, you can just concentrate on your networks and very specific applications.
Yeah. Okay, ma'am. Thank you so much.
Yeah, can you hear me?
Yes, sir, we can hear you.
Okay. Sorry to say that I was quite late due to some reasons. That's why I have not joined properly at that same time. But can you just for a second you can tell me what was the topic for you?
What was the?
What was the topic you have just discussed now?
Neha?
Neha ma'am, the session chair has a question for you.
Yes, sorry for I was on mute. It is analyzing existing cryptographic protocols.
You just show your first slide.
Yes, sir. The topic is analyzing existing cryptographic protocols, quantum key distribution, and post-quantum cryptography to enhance security in quantum computing world.
Okay, what is the basic conceptual? I'm just asking you a very basic question. You just given one slide like about the conclusion part. You just shown about the hardware declaration section, right?
Yes, sir.
What type of hardware you just implement over there? What is from your suggestion that type of hardware you just show the slide? Yes, here hardware optimization for QKD.
Yes, sir.
So what types of hardware it's required?
Sir, so for now, they are putting fiber optic cables. So a couple of experimentations are done in DRDO, but they have to be put in a remote location because noise or any other factors, any other parameters that are there might impact the data that we are sending. So totally, the data might change if it's not in an isolated
Have
situation.
you tested any data on this experiment?
Sir, for this, the setup that is required is very huge. Right now, we don't have that facility publicly
Okay.
available because it is confidential. So my work would be more on the software side. Hardware bit, I had an opportunity to work with one of the startups in Hyderabad, that is Quantum AI.
Which methodology, which algorithm you are implementing for this?
RSA, sir.
RSA.
Yes, sir.
Okay.
So I'll just summarize the hardware bit. So they came up with a small box from a big system to there is one startup that is developed a small box wherein they could generate these kind of, because quantum particles have to be manually generated. So these they have managed to come up with a small setup, and they have implemented that in IIT Madras, if I'm not wrong. So that work is going. So I'm quite dependent on the external resources for hardware testing. The work that I'm
already going, then what is your new implementation over it?
Sir, I'm merging the existing system with
Okay.
the QKD aspect that we have, and for that there are a couple of simulators available by Government of India, and second by IBM, which is in this field for last almost 30 years. So have we to test it on hardware? The options are coming up, but my work will be totally on protocol level.
Software. Okay, you continue with your work.
Thank you so much, sir.
Okay, thank you, Neha ma'am, for your presentation. Thank you, chairs, for questions. Now we'll move towards our next presentation. Our next presenter is Arya Devi MR, who will be presenting a paper on automated test case generation using natural language processing. Ma'am, Arya ma'am, are you in the session?
Yes, sir, I am here.
Yeah. So can you begin your presentation?
Yes, sir, I am sharing my screen.
Okay. Ma'am, are you facing any technical issues while sharing your screen?
Yes, I am facing some issue.
Okay, ma'am. We'll do one thing. You try to resolve your issue, or if you have any queries, you can just ping me in the chat box. Till then, we'll move towards the next presentation. We'll take your presentation later.
Okay.
Yeah. So moving towards our next presentation, it will be presented by Archana R. Who will be presenting a paper on evaluation of geospatial data conversion and integration methods for food security assessment.
Thank you for
Archana,
the
ma'am, are you?
introduction. Yeah, I'm sharing my
Uh,
screen.
yeah, sure.
So yeah, let me know when the screen is shared or is it visible?
Yes, ma'am. Your screen is visible and you're audible, so you can start your presentation.
Thank you. So good evening, everybody. I will be presenting a paper on evaluation of geospatial data conversion and integration methods for food security assessment. So to start with, yeah, so geospatial analysis, it's a process of gathering, visualizing and analyzing data that is linked to specific location on Earth's surface. So it helps to uncover spatial patterns and to visualize relationships and trends that is most likely invisible in traditional data sets that doesn't have any spatial attributes. So it is widely used in urban planning, public health sectors, disaster management, etc. And the problem here is many of the data sets in the real world, that is like census data or economic indicators, the climate readings, they are non spatial by default, and that is they lack the geographical attributes, that is the latitude and longitude and latitudes. So without having the spatial attributes, it is not possible to dig out the location-based patterns and to find the disparities. So this limits the ability to analyze the regional disparity, and it makes the location-based analysis more difficult. And it is important that because the spatial data provides more richer and more understandable action layers, it allows the stakeholders to see not just what the problem is, but to see exactly where the problem exists. And integrating non-spatial data into geospatial frameworks can improve the targeting's efficiency and impact in the decision making. And in this study, I'll be using food security as my case study. And food security, it is defined as when all the people and at all time they have physical and economic access to safe, nutritious food that can meet their dietary needs. So the data that is required for the study, most likely they are from different sources. They are multi-dimensional and often they are non-spatial by nature. And it makes it difficult to assess regional disparity or plan location specific inventories. And the objective of the study is to analyze the food security as the most lowest administrative unit and to utilize both non-spatial and spatial data for the study. And so we have taken 10 wards of municipal corporations from the southern part of India for our study. And from the previous literatures, we can see that they have emphasized the value of integrating various data into geospatial frameworks for insight, to get the insights on population, infrastructure, and resource distribution. So it is used to reveal the spatial disparity and hidden patterns, particularly to see at-risk regions. So the recent advances in distributed computing platforms, they have significantly improved the scalability and speed of geospatial data processing. Despite these advances, we have found the research gaps that lies in the lack of standardized methods for handling the data types, because it's mostly various data types and from multiple resources, and how to convert them significantly to a particular spatial format. And how there is a limited framework that systematically guides you throughout the process. And the current approach, they often do not address challenges like data quality, inconsistencies, and spatial non-stationarity, incomplete data, or scale mismatch in the unified framework. So what is the challenge that lies in addressing the research gap? It is that the data that you get may be inconsistent format, they may have the missing values, and it requires a lot of manual pre-processing and imputational techniques. Also, the scale of the data that you get differs the scale differs, and you need to, when you try to pre-process the data, it introduces another issue of resolutions. And the data, as you gather from different sources, they may have different projections and coordinate systems. Of course, and to handle the high resolution data, you may require a lot of computational complexities and so on. So what we did in our study is we gathered the data from different sources. So the data include food security source, socioeconomic status, population density, vegetation index, groundwater level, and farmland availability. So the sources of the data are mostly from publicly available data sets, government database, and remote sensing or satellite imageries. So we have used multiple conversion techniques for each of the data that we have gathered. Some of it is like geocoding and reverse geocoding. So whenever the data has the address or location, but it is non-spatial, we add the spatial attributes, that is latitude and longitude, to it to convert it into spatial data. And to convert this into continuous data, we use a spatial interpolation. So this is mostly used in groundwater level. And for certain data like the socioeconomic indicators or the population density, we need to add the administrative boundaries, that is another spatial attribute to make it spatialized. And in the image that you can see that the first two tables are non-raw data that doesn't have any spatial attributes and they have missing values. So we need to add the spatial attributes through geocoding, and you can visualize this as a vector representation. And after spatial interpolation, you will get a raster format of it. And this process is being done for all the data that we have gathered. And after this, we convert all the data sets into a uniform raster format, which is more helpful for geospatial analysis. And we address the mismatch in the scale and the coordinate system by bringing every data into one single resolution, that is 50 meter, which we found is more optimal through the study. And when the data is ready, we inputted all the data into QGIS spatial clustering for analyzing food security zones. And we applied various GIS tools to visualize the spatial patterns and correlations. So as you see, this is our result. That is, it represents different stages of food security cluster within a specific location. And how did we overcome the challenge? So we used a standard geospatial workflow in QS, and we...
Excuse me, ma'am.
Yeah.
Yeah, sorry to interrupt you, but you have got 2 minutes of time left. Please try to conclude your presentation in the given time frame.
Yeah. And what we did is we handled the missing data through machine learning techniques, and we formatted everything into one single format, and we developed a standardized protocol. And after completing the conversions, we validated it against the reference data. And as a result, we got spatial layers that indicates different diversities of food security. So in our clusters, we identify different classes of food security zones, right from lowest to highest. And the results shows that often the food insecure zones, they have high food stores, but low socioeconomic status. And the regions with agricultural potential, but they may not have the infrastructure and the zones that have critical scarcity of resources and vulnerability. So we compared our results with the historical data, that is the slum map that is available now, to validate our results. And yeah, to conclude, non-spatial data, when it is transformed to spatial formats, they will give rise to many meaningful analysis, and we can unify raster-based formats to enable the seamless analysis. So in our study, we used food security to explain how we can convert spatial conversions, and it can bring rise to dig out many hidden patterns. And the contribution of a study is we developed a practical spatialization format for varied data types. We address the challenge in scale mismatch, missing data. Yes,
Okay,
sir?
anyways, I have understood whatever your presentation. Quite, I'm asking some question. Are
Yeah.
you ready? In the one of the slide you have just presented that in the literature insights, right? You
Yes,
have
sir.
written it is used to reveal the spatial disparities and hidden patterns, and preferably particularly at the risk region. In
Yeah.
which type of risk regions you are working for that?
So I am working on food security, so we can know exactly where the food insecure regions are. So currently there are studies that are going done in a national-wide level, not localized levels like the lowest administrative zones. So there is no localized studies there. Yep, that's one of the thing. And in the previous literatures, they have only used the spatial data that is available, but I have used I have tried to include non-spatial data as well for the study.
But it has the research gap, right?
Yeah, that's the research gap.
Okay, and one more thing, like in the next slide, right, like in the spatial interpolation, you are using the technique like spatial interpolation, right?
Spatial interpolation. Yeah.
Okay.
Here.
What is the basic concept over there? Because you are converting continuous data.
We are converting to continuous data.
Yeah.
Yeah.
How will you convert? What is the methodology behind that? I'm just asking for that.
Yeah, okay, sir. So the process is that we will be taking the known values to predict the
Okay.
unknown values. It's the basic interpolation technique that we use in our statistic and mathematics. But in spatial, when it comes to the spatial analysis, we also take in the spatial relationship that it occurs. So we have something called spatial autocorrelation. We keep that in mind while doing the interpolations here. This
Have you done some analysis about those data?
Yes, sir, we have done for all of the data, which is like point data. We have included spatial interpolation to make it continuous data to get the raster
Is
format.
there any analysis results? Will you show by the graph or any ways?
I haven't included any graph for it, but as you see here, in the image, you can see that the vector representation, but this is the data that we have inputted to the spatial interpolation, and we get the raster format of it. So this is the basic idea behind it, and this can be done using various QGIS tools as well.
Okay, means you are also working now, no, with this thing?
The work is almost done, sir, here.
Okay. Is there any work before that? What work has been done over this?
The work I have done or in general?
In journalism, previously, what type of work over these has been happened?
Uh, yes, sir. So there are many disaster management things. There are analyzing the landslidings for to particularly understand which area will be affected more and why it will be affected, kind of things has been done earlier using these methods.
But you have not mentioned what is the earlier work has been done. That should be over there, right?
But I haven't done it. It is in particular because there are a lot many applications of geospatial analysis, and it's not possible for me to mention everything here.
Okay, is there any query from any others?
Okay. I have a kind of doubt. You're only taking a spatial data set, right?
No, ma'am, we are taking all
Why
of the.
have you not taken the time domain or temporal?
That is in our future work, ma'am, because now I have just analyzed it in a spatial way. So we need to add the temporal aspect as well for having the prediction
And
side.
one more thing is you have said about food security.
Yes,
What do you
ma'am.
mean by food over here?
It is the accessibility to food stores. You need to have the availability, that is the economic access of it, and you need to have the infrastructure, and if to analyze if the particular region is sustainable.
No, no, no,
Not,
no, no, no.
yeah.
My question is, what is the word food? Are you talking about cooked food or uncooked food or vegetatives or which one?
It's not, yeah, it's not the cooked food, ma'am. It's basically the food that is available in the market, whatever it is in the raw form, like the
So
vegetables
that
or the
should not be put
groceries.
as a food, right?
Yeah,
Food is something which is consumable. So I think you can also make a note of that, like it's not the food, maybe the raw vegetables, because you're taking into consideration the farmland and the groundwater and all into consideration. I think you can also include, see, you having temporal into your future work is not going to help you right now, because while analyzing you're supposed to include your time domain also. So
yes, ma'am. So
because
this
what is
this
the
particular study is done in the last few years of data, like 5 years of data we have crawled. So it will be having the temporal aspect of these 5 years. But what I mean by saying like temporal aspect, like we need to have a forecasting system as well for this. So we need to have the historical data alongside.
so you're not having or you're having?
The data crawling is being done, ma'am, but that is not being discussed in this paper.
Okay, for better results, it is better you have the time domain also.
Okay, ma'am. Yeah, I will include that as well. Thank you for the insight.
Yeah, thank you. That's all from my side.
Okay. Yeah.
So if there aren't any further questions or remarks to make on the paper, thank you, ma'am, for your presentation. We'll move towards our next presenter.
Thank you.
Our next presenter is Mr. Sanjay Agal, who will be presenting his paper on improving robustness and accuracy in unsupervised domain adaptation. Sir, are you in the session? Any co-authors associated to this paper? Okay, we'll move towards our next paper. Our next paper is going to be presented by Mohammad Hussain Osman Al-Nagib, who will be presenting his paper on MGH YOLO lightweight model improved YOLO V8 for real-time brain tumor detection. Mr. Mohammed, are you in the session?
Yeah, I'm in the session.
Yeah, so can you begin with your presentation?
Okay.
Yeah.
Okay, our paper title is MG YOLO Lightweight Model Improved YOLO version 8 for real-time brain tumor detection. The contents of the presentation is an introduction, problem statement, the method, experimental setup, performance metrics, results and visualizations, application study, conclusion, and future works. As in introduction, there is an importance for early brain tumor detection, and that will impact in the recovery and treatment plan. From where we can detect the brain tumor, there is 3 scans, CT scans, PT scans, and MRI, but MRI is a golden standard for imaging methods used for brain tumors. And there is a traditional method for detecting brain tumors and classic machine learning methods, including CNN, and deep learning models include YOLO models. There is a need for optimized model for small tumor detection. The limitation of traditional detection methods This method struggle with the detection of small and complex tumors. These methods overlook many tumor area, leading to inaccurate diagnosis and delayed treatment. Also, these methods has a complexity and a variability of brain tumor pose challenge for conventional detecting algorithms, and that is a need for advanced and efficient model. And this is instant and future directions for the instant researches, including real-time and personalized image and ethical considerations. As a background, there is a lot of publications in this field. The more interested models is YOLO version 5 and YOLO version 8 has a high speed detections. Other models like RCS YOLO and DAMO YOLO show potential but lack efficiency. And there is a challenging in detecting small tumors with precision. Our problem statement is traditional YOLO models struggle with small tumor detection, and there is the available models has high computational cost and memory usage, and there is a need for real-time processing for medical applications. Our methods is based on YOLO version 8 architecture. This architecture is predictable, and it consists of from 3 main components: backbone, neck, and head. Our model architectures is used GOSCONF for computational efficiency and replace CTF modules with C3 cost for efficient feature extraction. Also, we are employing SPPE LAN module for enhanced multi-scale vision. Also, we add a new detection head for detecting extra small or extra small tumors. And as we see in the picture, this is our model. Here, the backbone is consists of GHOST and GHOST-CONF and C3 GHOST. There are lightweight modules used for feature extraction and feature fusion. Also, we used SPPE LAN to enhance multi-scale feature vision. And instead of large object detections, we used small object detection for detecting X small tumors. That is enhance our models to detect X small tumors and small tumors also with medium and large tumors. Experimental setup done on the dataset. It's a public dataset called PR35 dataset. It consists from 801 MRI images. We use 641 for training and 160 for validation. We use Google Colab Pro with NVIDIA Tesla T4 GPU, 25 GB of RAM. And our hyperparameters, we training our model for 100 epochs. Batch size was 16, and initial rate was 0.01. Optimum of is 0.937, and MX size is 640. Also, we use pre-training weights. We training our model in the same dataset for some epochs, extract the best weights loaded, and training our model again for 100 epochs. After evaluation our model, we got precision 96.3, recall 96.5, mean average at score 0.5, it's
Excuse me, sir.
98. Okay.
Yeah. Excuse me, sir.
Yes.
So yeah, I wanted to inform you, you have 2 minutes of time left to conclude your presentation.
Okay. When we compare our results with others available studies in the same data set, we find that our model got a high precision, high recall, high mean every precision at 0.5 and 0.5 to 0.9. And this is a visualization of the results. There is a sample, 4 samples from the data set, and we can note that our model accurately can detect and localize where is the brain tumors, even if there is some 2 or more than brain tumor at the same time, it can easily detect them. And when we compare our model to the base model, we can note that we use 16 million, 12.6 million parameters and 96.9 G-flops. As a conclusion, we can say that we use light design makes it suitable for real-time applications. Our model surpass existing YOLO versions in brain tumor detections. Okay, thank you.
Okay, sir. In the second or third slide, you have shown about the architecture overview, right?
Yeah.
Yeah, in the slide. You have skip out. Go with that slide. I think, yeah, architecture overview. Here you have in the previous one.
Okay.
Here you have written the backbone, architecture overview backbone, like feature extension, SPPF, C2F, and what is this? I just asking from you because this is quite different.
Yes, yes. Backbone, YOLO version 8 architectures is the backbone is consist of some modules. Huh?
What is the C2F? What is this?
This is a module used for multi-scale facial fusion in the same architecture of YOLO version 8. And instead of SPPF, we use SPP ELAN. This module is used in YOLO version 9 for enhancing multi-scale feature fusion. And we'll keep the cost and lower and keep the accuracy at the same level.
Okay, then I am asking you that previously, whatever the treatment are going about the tumor of site, brain tumor site, is your experiment will be successful? How much percentile will be? How much accurate will be the result from your side?
From my side?
Yeah, if you apply these methodology, these experimental view over the conceptuality of your like brain tumor, whatever you are just explaining, then in that, what will be the accuracy?
Yeah. The accuracy of our model here, as you said in this slide, is 98.6.
How you have got this result? Where you have
by training I training our model in the public data set. It's called this data set. We training our model in this data set, and after that evaluation our model in the same data set by putting a new image. The model didn't say it before, and after that you can calculate and evaluate according to this 4 evaluation matrix. What's the performance of the model?
Means as per your decision that it is much more precise.
Yeah, this model achieves more precision than others.
Okay, now then as per your side that it can be implemented, right?
Yeah, it can be implemented.
Then now tell me, what is the technology or methodology, means algorithms you are using, where you have mentioned about that?
Algorithm, it's a YOLO model. We can implementing in the medical application in some hardware. It's going on research for that.
Have you mentioned the algorithm here?
YOLO version 8.
You know how the algorithm will operate. Have you shown there?
You okay? Yeah, here the image is coming from input side to the backbone. Backbone makes the feature extractions from the image and feature fusion to decide which area. And after that, according to the data set, because each image has a TXT file, includes the labeled region, includes the tumors, and the model done how to extract the features of tumors and differentiate it from another regions and decide this is a real region from includes the tumors.
Means you just experimented over a small object, right?
Yeah. We add here small object detections for detecting extra small object, which is not available in YOLO version 8 baseline.
Okay.
Okay.
Thank you.
Thank you.
Okay. I just have one query. Like YOLO 8. Why have you chosen YOLO 8? Because we have right now YOLO 11 itself into the market. Why are you with YOLO 8?
Yeah. Because all the YOLO versions behind YOLO 8, YOLO version 9, YOLO version 10, YOLO version 11, and even YOLO version 12 launched this year. All of them is built on the YOLO version 8 architectures. It's adaptable architectures. You can easily manage it and adapt it to your own module.
Yeah, but you have not made any modifications. No, you have used it just like that. At least if you had done any hybridization, I can accept you are not going with YOLO 11. But when it is only YOLO
No.
base model, yes.
Okay, we use here this module for feature fusion SBB ELAN. This model is used in YOLO version 9. And I'm just use same architectures of YOLO version 8, but all the modules inside is different. We use Ghost Conf. YOLO version 8 use Conf modules. YOLO version 8 use CTF, C2F modules. We use C3 Ghost modules. YOLO version 8 has head detections for small, medium, and large objects. We use X small, small, and medium detection. Yeah.
Okay. And your input is MRI scans, right? Or PET scan?
MRI scan.
Why have you not gone with PET? Because PET is even more detailed version, right?
Yeah. But there is a lack in the dataset. Available dataset right now, it's all of them. It's MRI image.
Okay, but more than MRI, PET gives more detail. So you can just try. If you are planning to continue this work, you can try on PET images.
Okay, will be in our futures working.
Okay, that's all from me.
Okay, thank you.
Okay, thank you, sir, for your presentation. We'll move towards our next presenter.
Okay, thank you, sir.
Our next presenter is Pooja Singh Chaudhary, who will present a paper on object detection and tracking insights leveraging methodological approaches.
Yes, good afternoon, sir. Which I'm
Good afternoon,
presenting.
ma'am.
Okay, I'm sharing my screen. Is it visible, sir?
Yes, ma'am, your screen is visible.
Okay.
Yeah, there's one thing, ma'am.
Yes.
Quite disturbance in your background, I guess. So Your voice is not clearly audible.
Now is it audible, sir?
Yeah.
Okay. My screen is visible, right, sir?
Yes, ma'am. Your screen is visible.
Okay. So, my name is Pooja Singh Chaudhary. I'm a main author, and my corresponding author is Nirav Bhatt sir and Purvi ma'am. And my title is Object Detection and Tracking Insights Leveraging Methodological Approaches. Here we have done the literature survey for all the papers which we have read out, and these are the outlines. First is our introduction of object detection and tracking literature survey, motivation by that um, literature survey, our research objective, problem statement objectives, and some expected contributions to the proposed work, research methodology, and which kind of data sets are used in those papers, and some design research workflow, and some expected outcomes. This is the introduction to that object detection, that why object detection, how it works. It used for identifying and locating the objects of the interest with an image or video frame, and it is used in the applications field such as the surveillance and target
Pooja,
objects.
sorry to interrupt. Can you put it in a slideshow mode? And if you're using are you using a Bluetooth speaker or something else? Because there's a disturbance.
I'm using my earphone.
Okay, then don't put the mic too much near to your mouth. Just put it little bit away, and put it in a slideshow mode, please.
Yes, ma'am. Now it's okay, ma'am?
Yes, now it is fine. But slideshow mode, please.
Okay. Oh, it's fine, ma'am?
You're audible.
No, ma'am.
Fine.
We aren't able to see the slideshow.
Oh, okay. Then maybe my network is down. Let me check. Okay, you can continue.
Okay, ma'am. So, firstly, the object detection, which focus on identifying and localizing the objects within the image and video frame, and after that, the tracking has been done for involving the continuous monitoring and predicting the movement of the identified objects, which has been done across the frames. So, this is the fundamentals of that. And here we have used the frame, paper has used the frame to frame tracking for tracking the object after the detection has been done of that particular object. And after that, the optical flow is used. It's a kind of a technique which is used for the identify the velocity of the objects in the particular video frame to frame. And lastly, the Kalman filters, I have identified that we can use that to predict and update the state of the object to estimate the future state of that particular object. So this is the whole concept of the object detection, that firstly the object has been detected and the tracking of the object has been done, and basis of the object track, the concept of the velocity and the prediction of its future motion has been analyzed. So it has been done in the various fields such as the robotics, video surveillance, and the augmented reality, and algorithms such as the Kalman filters and the Kalman filters has been used to predict the future positions to enhance its tracking and the reliability of the object or the target. Then again, the velocity estimation has come into the picture after the tracking. That, for example, it has been given that imagine an AV, that is our autonomous vehicles. If you are driving on a highway, so if a vehicle approaches another car in the lane ahead, so the sensors can continuously track the car's position and the speed, so that the vehicle can safely navigate the traffic by avoiding all the collisions or the dangers uh, in the particular situations. So for that, we can use the estimation of the velocity of the particular object or the target we are targeting. Then after that, the path prediction comes into the picture. Then firstly we have done the object detection of the object detection, then after that the tracking of that object, and after that we have estimate the velocity of that particular object, and after that lastly we have predict the path of that particular object, that whether to analyze the angle or the speed of that particular object for the future position. So this is the concept for the path prediction. And this is the representation for the visual object detection and the tracking. That firstly, the video, the data set can be in the form of an image or the video, and then it convert it into image frames. That V3 object detectors will YOLO is having the full form of the you only look once. It is used for the object detector. Then the object bounding boxes come into the picture for the sort tracker, and with the help of the unique ID of the object, it will be identify or it will be detect the objects in the given picture. So here I have done some literature survey or literature review on the papers. So firstly, in the conclusion of that, we have found that research models for some papers has been used CNN and RNN models, and YOLO deep neural network is also found as a key contribution to improve our tracking continuity of the targets in the video sequence, or if we are taking the data sets as in the form of an image, so it will also work. So outcomes are that it should improve the multi-target detection and the tracking of that particular object, and also with the some algorithms what we have defined, as we have defined over here the Garman filters, we have defined optical flow techniques, we have defined over here. So so this is the outcomes of the this papers, and after that, so YOLO and OpenV, that are the research models in which the real-time detection of the object has been recognized to speed in tracking or locating the object in the context of the accuracy or the efficient
Excuse
in
me,
the
ma'am.
real time. Yes, sir.
Ma'am, it seems that you are still stuck on the introduction to object detection slide.
1 second, sir. It's not changing, sir.
No.
Okay, wait a minute, sir.
Yeah, now you're on the motivation slide.
Okay, fine.
Yeah.
Now I can continue, sir.
Yeah, sure, ma'am. You can continue. Also, you have 3 minutes left to conclude, so please sum it up quickly.
Okay, sir. So after that, this is the motivation derived that from the real-time object detection and the tracking prediction, the goal is to achieve that however by detecting and tracking the objects in the real time and predicting their future states by these systems can proactively respond to the potential hazards and optimize those operations and improve the decision making and the performance analysis. So this is the motivation we got by doing that the literature survey. So here these are the research objectives. As it is mentioned that we use to estimate the reliable velocity. We can use to make the system robustness. We are used to predict the target localization for improving the decision making and the performance analysis. So these are the research objectives that we have concluded from those research papers. Okay. So on basis on the research objectives, so we are addressing that this is our problem statement. We can define that deep neural network models are evaluated using some in the real world data sets with the prediction of the error to improve the reliability in the real world scenarios. So here I have kept the tracking of the object, that how it will go in the flow. Firstly, the target initializations has going to be done. Then the first step of the object targeting is defining the number of the targets and the objects of the interest. Then after that, the appearance of the modeling, then target positioning, then the motion estimation. So here is the concept of the how we are going to track our particular objects. these are the research directions that we can use the transformer models and the CNN and and deep sorts kind of multi-object tracking for the betterment and efficient improvement of the real-time accuracy and efficiency with this hybrid algorithm. Here I have put the research design flow diagram. So firstly, we can take the input and after that we can pre-process those inputs in the form of the image and the videos. Then object detection, object tracking, velocity estimation, path prediction, and lastly the output visualizations can be done. So this can be a research design flow diagram I have created with the from the literature review survey. So this is again the explanation of the diagram only, that how the videos are analyzing from frame to frame and the object tracking, how we are predicting the next state or the future state of that particular object after tracking has been done. And after the tracking, how
Excuse me,
the
ma'am.
velocity, yes.
Yeah, ma'am, please conclude your presentation in 1 minute.
Yes, sir. Okay. So this is the velocity estimation after the tracking and the path prediction we have done. And so lastly, the conclusion is that, so to validate the conclusions from the comparative analysis is by connecting the detection across the frames over the time of the object tracking algorithms, that it use the bounding boxes and the centroids and the label pixel regions from the detection outputs. So future work can be done, then it can improve more the accuracy in the real-time performance and adapt all the advancements in the deep learning. So these are some data sets we found in the literature survey. So we can work on this. Data sets can be in the form of a video or the image net. So these are all the reference, and thank you. If some questions are there.
Yes, madam. Just one question. You
Okay.
just explain that, ma'am, can you elaborate that how your approach integrates between the both detection and tracking, right?
Yes, sir.
It's a single framework.
Yes, sir. Actually, sir, it's not a single framework. It's a different frame. There are can be 1,000 of frames, sir. Because videos we can only we can train our model in the frames only. If you are using image data sets, so there is no need of frames. But if you are using data sets in the form of a video, so you need to train your model in a some frames, sir. So for that particular thing, I have used the word frame for the video data sets.
Okay, madam.
Okay, sir.
So, ma'am, in tracking, are you considering this occlusion detection also?
Yes, ma'am. Some if the occlusion handles, so we are having some filters. I have found from the literature survey how to avoid all the occlusions which come in the path of object tracking. So Kalman filter is there, optical flow technique is there. So we
Kalman is a very old filter, no?
But
They
ma'am,
used
for that particular data sets for the autonomous vehicles, that filter is, you can say that it's a robust.
we
So,
have extended Kalman and we have many other advanced filtering techniques also.
okay.
You can check like collision avoidance and occlusion also you can.
Okay.
You will be able to include.
Okay, ma'am. Definitely. Sure, ma'am.
Thank you.
Okay. Thank you.
Okay, thank you, ma'am, for your presentation. We'll
Thank you
move
so
towards our next presentation. Our next presenter is Arya Devi Emma will present a paper on automated test case generation using natural
much.
language processing.
नहीं हमको ऑनलाइन रहना वो कोई
Arya ma'am, are you ready?
Yes, I am ready.
Yeah. You can share your screen and begin your presentation.
Yes, sir. Sir, I face a difficulty in sharing my screen.
Okay, ma'am. Just ping me in the chat box the issue. We'll resolve it. Till then, we'll go to the next presentation.
Okay, sorry, sir.
Our next presenter is Mr. Sanjay Agar, who will present his paper on improving robustness and accuracy in unsupervised domain adaptation. Sanjay sir, are you in the session? Okay. Our next presenter is Shipra Agrawal, who will present a paper on recent trends in cryptographic techniques for securing ZigBee IoT devices. Shipra or her co-author Manish, any of them in the session? Okay. Moving forward, we have Bei Gwen Van to present his paper on Sumen end-to-end transformer model for image to latex with enhanced performance and large data set. Mr. Bei, are you in
Yes,
the
I'm here.
session?
Yes, I'm here. Thank you.
Yes, sir. You can begin.
I'm sorry, I have to check the technical things along my side a little bit.
Sorry, sir.
Well, I have some technical issues, so I have to check again before I can present.
Okay, so you are unable to share your screen?
Yeah. I'm not able to share my screen.
Okay. So we'll get that covered in the chat box. Till then, we'll move towards the next session. So do we have Mr. A.M. Hafiz to present his paper on a novel technique for security augmentation of cryptographic algorithms? Mr. Hafiz or his co-author, are they here? Okay. Mr. Sanjay Agal? Ms. Shipra Agrawal? Okay. Respected session chairs, it seems that the two authors present here are facing some technical issues for sharing their screen. Can we just resolve in 5 minutes and resume the session again?
Yeah, okay.
Hello.
Yes.
Yes.
Thank you, ma'am. Thank you, sir.
Dr. Sanjay is available.
Okay, Dr.
Sorry,
Sanjay, then
now.
we can go with your session presentation then.
Sorry, I trying to share my screen. Is it okay?
Yes, sir. I'll ping. Now begin with Sanjay Agar, who will present his paper on improving robustness and accuracy in unsupervised domain adaptation. Sanjay sir, you may proceed.
One second. I'm starting sharing.
Yes.
I think I am having some technical issue. I'm joining in 2 minutes again.
Okay, sure, sir.
Within 2 minutes, I'm joining. 2 to 5 minutes.
Yes, sir. Yeah, ma'am.
Hello, sir. Now I can able to share my screen.
Yeah, if you are able to share, then you can share your screen. We'll begin with your presentation then.
Yes, sir. I shared my screen. Is it visible?
Yes, ma'am. Your screen is visible.
Okay.
Yeah.
Sir, can I continue?
Yes, ma'am. You can continue.
Okay. Good afternoon, all. Myself, Arya Devi, and my presentation topic is automated test case generation using natural language processing. And my co-author, Dr. Abdul Jabbar. And let's move on to the presentation outline. My presentation consists of the introduction, background, methodology, experiment results, discussion, conclusion, and the references. Firstly, moving on to the introduction part of this presentation. The automated test case generation, which simply means the generation of test cases using automated tools and models. So in the production of a good quality software, we need good quality test cases. So software quality assurance has become the essential aspect of the software engineering processes. Traditional methods, which include the use of manual test cases, where it is very much of time consuming and consist of very less coverage. So in order to build a good quality software, we need uh, most modern approaches, such as of natural language processing, which improves the clarity of generated test cases while ensuring high coverage and improve the overall software quality. And there are various techniques for test case generation, such as for traditional methods, such as of model-based testing, using various script modeling, and were we coming out to the new era of deep learning approaches, where we use the transformer based models such as of ChatGPT, path language models in order for generating the quality test case. So the large language model based testings, which were be involving the rule-based test approaches, will increase the quality and reliability of the generated test case. So rule-based approach will help to enhance the overall test case generation process by the use of predefined rules, which help to eliminate the irrelevant test cases. The main objective of the automated test case generation is to create the test suite autonomously without any user interaction, which helps to achieve the high coverage matrices. So moving on to the background of automated test case generation, where the software testing is a crucial component of software development lifecycle, and where the previous literatures were mainly focusing on to the topic of search-based software testing techniques, and which involve the main use of genetic algorithms and the various expansions related to that, which will be mainly using for the automated test case generation. And when coming on to the new era of technology, where large language models will be using in order to generate the test cases, where the use of ChatGPT models, such as the latest of GPT-4, the path language models, which are the transformer architecture that can be used in order to build greater quality test cases that can be understandable from the human languages and can generate high quality and reliable test cases. And by telling about the detailed background of search-based software techniques, which involve genetic algorithms-based approaches and its expansions, which include various kinds of particle SAM optimization techniques, simulated annealing approaches, various differential evolution approaches, and the combining of different algorithms all together called the hybrid approaches that can be most prevalently used in this scenario, and which coming on to the latest literatures were focusing on to the use of large language models such as of GPT and pathway language models. There have been a substantial advancements in large language models with the creation of this model, where we can handle the more complex data in order to generate the test cases. And for the future aspect of the automated test case generation, we can use NLP techniques, where we can combine various hybrid approaches all together to ensure the generation of high quality test cases. So by moving on to the main methodology of this automated test case generation using natural language processing, will consist of several key stages. Firstly, we start with the selection of relevant projects, gathering their functional requirements. After that, we are combining that to make large language models through an API application programming interface services in order to produce test cases aligned with the kind of requirements. And after that, this generated test cases are added to a test suite, which means the collection of test cases to evaluate whether they can run successfully with the specified requirements. And finally, we are assessing the quality of the test cases that produced by analyzing its coverage and their effectiveness in supporting the functional validations. This is a diagrammatic representation of our methodology where the project selections and requirement gathering were being combined to the large language models such as of GPT model and pathway language models, where we are generating the automated test cases and where we are combining all the automated test cases to a test suite and finally evaluating the coverage of that test cases. And the methodology also include the rule-based approach to generate test cases, which is mainly focusing in order to eliminate the invalid test cases and to improve the quality of automated test cases, modify the original set of test cases using a set of specified rules, and to guarantee the accuracy of the test suite and to ensure mainly the overall coverage of test cases. And by moving on to the main metrics of this automated test case generation, which consists of 4 main metrics that we are using: executability, validity, relevance, and coverage. The executability metrics will ensure that the generated test cases compiles and run successfully in the project environment without the modification, confirming syntax and compatibility. The validity will ensure the test case accurately verify the internet functionality as per the requirement, where we can distinguish the valid and invalid test cases. And the relevance, the next metrics were evaluate how well a test case align with the core intent of the requirement, ensuring the meaningful and essential functionality testing. And finally, the most important metrics, that's the coverage. We're assessing the extent to which the test cases cover project requirements, including the code level. We have different types of coverage metrics, such as of line coverage, branch coverage, path coverage, etc., and requirement level metrics for system reliability. So these are the 4 main metrics that we are using to evaluate the automated test case generation approach. And by moving on to our experimental results, the OpenAI API translates natural language requirements into functional test cases with an average executability rate of 62% in the single generation attempt. In the graph, we can see the executable rate of test cases by single generation and multiple generation. Where the key categories, which including user authentication, data processing, and profile management, were improved the executability rate to 75%, demonstrating the benefit of these multiple iterations. The finding highlight that the potential of large language models in automated test case generation with iterative refinement enhancing the accuracy. And the next
Excuse me,
results.
ma'am.
Yes, sir.
Yeah, you have 1 minute of time left to conclude your presentation.
Okay. Oh, okay, sir. So our next result, which focusing on the comparative evaluation, were focusing on to the comparison of OpenAI generated test cases versus the manually created test cases. And the performance here, the AI generated test case achieved 38% validity rate and 30% relevance rate. And the manual test cases were 85% validity and 78% relevance. And the key insight were manual test case provides superior accuracy and coverage. Where we can move on to the next results were the validity and relevancy improvement, which consists of validity increased 38% to 55%, relevancy improved 30 to 48%. And the key insight which following, domain specific fine tuning enable large language models to better understand and handle the complex requirements. And the OpenAI capacity to handle the novel requirements was evaluated by the functional scenario that has not been previously encountered in selected project category. Results show that the 58% of generated test cases were executable, 48 were be valid for new requirement. And this suggests that OpenAI API is capable of generating new requirements to reasonable extent. Well, when we are dealing with the incomplete requirement, the OpenAI may encounter difficulties since it may produce irrelevant test cases. So in this we can produce test cases that can enhance by integrating the API with the rule-based systems. We already mentioned that it eliminates the invalid test cases. This is the graph showing the comparison of precision recall and F1 score, and showing the performance metrics over time using the precision recall F1 score and the single generation execution, single generation validation, and that of the multiple generation execution and validations. And these are the results table that consist of the user authentication, data processing, profile management, system notification overall. And we are discussing about the OpenAI generated and manual test cases, which are comparing which taking the benefits of both the aspects of OpenAI and manual test cases together. And the when we are combining both manual and automated test case together, we can ensure the accuracy, reliability, and overall coverage of the automated test cases. And for the conclusion, the NLP is an emerging approach that enhances efficiency and accuracy in automated test case generation, where human readable requirements can be interpreted, and it reduces the manual effort, and we can reduce the error that causing by and improving the test case scalability and readability. And the using of the LLM models such as of ChatGPT rule-based systems shows a promise in generating high-quality test cases. And these advancements in LLP can lead to the scalable and efficient automated test case generation, seamlessly integrating into software development processes. So the integrating automated test case generation into software development, it ensures the scalability and efficiency of test cases. And these are the references. Thank you.
Yes, madam.
Isa?
Ma'am, you are using NLP technique.
Isa. In order to generate automated test cases.
Okay, I am understanding. But madam, will you compare the symbolic approaches to NLP, which will be versus with modern transformation-based models? I mean to say that model choice and potential trade-off, right, between the rule-based and ML-based NLP.
Yes, sir.
Will you elaborate this thing here?
Sir, using the natural language processing, which is an emerging approach to this automated test case generation. Usually in the software industry firms, this approach is only be starting. Most of the firms be currently using the traditional approaches of test case generation, such as the manual methods. And now the use of OpenAI related test case generation is now only being started in the firms. And it's actually the new area to automated test case generation.
Did your work exploring this means NLP versus model transformation based models?
So now I am searching onto this topic using various tools and techniques such as of Selenium.
Because that is very important and very much related to the current era.
Okay, sir.
Have you explored about that on this topic? I think you have not done about anything related to that.
Yes, sir. I've been explored to this NLP related tools and techniques.
Yeah. That will be much more better, right?
Yes, because it helps to understand the human readable and we can interpret in a more accurate manner and to increase the coverage of the test cases, because test cases
that will be much more better to conclude about the paper. Much more understandable for that. You should add those things.
Okay, sir.
Okay, ma'am.
Okay. Arya Devi, I just have one thing. Like you told about rule-based system, right? Rule-based system nowadays is not at all even accepted in AI form. Using that rule-based system for NLP, so what kind of test cases will you be using?
Role-based systems I just mentioned as a case study.
Yes.
In order to validate how NLP can be more uh, how NLP can more achieve more accuracy and coverage.
With role-based system, you cannot achieve more accuracy. See, basically, it depends upon the data set or the case study which you are going to take. If it is just a traffic light system, okay, then if the person is jumping, then you can apply with the rule-based system. But say suppose it is legal law kind of things. In that case, you cannot apply a rule-based system. Even OpenAI, they don't have a specific data set for the Indian law system to be covered. Okay, so whatever you have done is a generalized study, but if you're going to work on a specific target, then you need to change your data set and the way in which you have projected NLP itself.
Okay, ma'am.
Okay, just take care of it.
Okay. Thank you, ma'am.
Thank you.
Okay, so we'll move forward towards our next presentation. Our next presenter is A.M. Hafiz, who will be presenting his paper on a novel technique for security augmentation of cryptographic algorithms. Mr. Hafiz, are you in the meeting?
Yes, good afternoon, everyone. Am I audible?
Good afternoon, sir. You're audible.
Okay, thank you. Can I share my screen?
Yes, sir. You can share your screen.
Okay. Can you see the PPT?
Yes, sir. The PPT is clearly visible.
Okay. Thank you for giving me this opportunity. I understand I have about 12 minutes, so I'll try to make the best use of it. My name is Dr. Hafiz. I'm a senior assistant professor at University of Kashmir, Srinagar at Institute of Technology, and this is a joint paper with me and my scholar. The title of the paper is A Novel Technique for Security Augmentation of Cryptographic Algorithms. And I will quickly discuss the innards of the paper. We have various security algorithms, cryptographic algorithms like DES, AES, and RSA, which are the three studied algorithms in this work. And what we have tried to do is we have tried to ensure that the key, if it is stolen, if it is pre-shared or it is shared over the line, it remains safe and it cannot be misused by using a local modification in the key. And that modification can be the appropriate data for modification in the in terms of a seed can be shared over the line or it can be pre-shared. So let me get to the presentation. These are the contents. Now, just a minute. Just okay. So we know that there are many recent algorithms also like now quantum computing has come. It has changed the whole scenario. China has developed quantum computing based encryption protocol, but still there is a mainstay for some time as we are seeing of advanced encryption algorithms like RSA and ASDS are rather older, but we kept them for a perspective that our algorithm which we propose or our modification, it's a slight modification, not a huge modification, an incremental approach which we propose is effective and can be used with various algorithms. Now, some discussion of the background of the algorithms. DES data encryption standard, the key size is 56 bits. AES key size varies, it can go up to 56 bits. RSA, it was developed by three gentlemen, Rivest, Shamir, and Edelman. The key size goes up to 4096. And RDS was old, then came AES, then came RSA. So RSA is, I would not say exactly state of the art. Like I said, quantum computing using Shor's algorithm and others have really put a challenge and are giving a tough time and will give a tough time to encryption algorithms. And some literature survey um, we have included from 2119. There is the relevant one of the papers which we were trying to come which we think is relevant is using an XOR and AND function. You can see it here, this XOR and AND. It is also relevant, but the point is that XOR has a 4 by 4 table. Rather, I would say 3 by 4 table, and is again a simple operation, but this is one step higher. What we try to do is we try to use a binary function at certain locations in the key. I'll come to that. So problem statement is vulnerabilities to sophisticated cyber attacks and maintenance of key security. Objectives, what we did is we took the key, it could be of DES, AES or RSA, and we applied a random seed. The random seed has to be known both by the sender and the receiver, and the random seed ensures that mutations in the form of only not, that is not, means one goes to zero or zero goes to one, are introduced in the key at fixed locations, and they are done once the key is transmitted pre-shared or shared over the line. And once the key arrives successfully at the receiver, the check can be made that whether the key is working or not. If the key is not working, then it means there's problem. So we will make sure that we invert, like we did the not operation on the sender side. Then the key is transmitted. He doesn't know where to attack, what to do with the key. If he uses the key as such, in between, he if we have this Alice Bob thing, and if he intercepts the key, since the some bits in the key are inverted, the key will not work for decryption. So what we do is we take the key. If he steals the key, it will not work. The key has to go to the receiver. There again, the not is run on fixed binary digits in the key, and then the key is used for decryption. This is some overview of the process. You start generate the key pair, you do some masking using a knot at certain locations, then you compute entropy just for observation purposes. You don't have to compute entropy for the actual mechanism. This is just for observation. Then you do unmasking at the receiver and then use it. The mask array locations, if you take a seed of 1 2 3 4 and you use the Shannon algorithm, for example, for obtaining the key, or for I'm sorry, not for obtaining the key, for obtaining the entropy, you see that the entropy increases, which is a favorable thing. It means the randomness of the key has increased, so it's a favorable thing. I'll be discussing that also. And these are the locations we generated for seed 1 2 3 4, which is a random seed for a random number generator. And these are the locations 1 8 24 44. These are the location of the bits which will be inverted or knotted, not knotted, which will pass with a not gate. 1 will become 0, 0 will become 1 in the whole key. And for 1 2 3 4 seed, it goes up to 97. Let me show this here. For example, you can see here, let's say this is the original key of RSA algorithm, and you see here that now this is the begin public key. You see the first here we first had a dash, and here it's a comma, so this is inversion, and inversion is a specific location in the ASCII bit sequence. Then you have a dash here, here you have a 5, here you have a 5, so this is the masked key. Then for example, here there's a here, here you have a question mark. The masked the A has been masked at a certain location defined by the random seed. Then once you unmask it, you again use a random seed to unmask it. You invert it from not gate, you invert the key, it again becomes the origin key and can be used. These are identical. Origin RSA and unmasked is identical. The masked key is transmitted over the channel.
Excuse
So it's
me,
a
sir.
fairly simple approach. G.
Yeah, you said I just wanted to inform you that you have 2 minutes of time left to conclude your presentation.
Yes, sure. So this is for AES. AES again, it's the key is smaller because it's older, earlier than RSA. So again, this is the origin key masked, and this for DES the key is smaller. You will see here certain permutations at F is 0, you have 6. Here you have a greater than sign. Then the entropy you will see here for DES, the entropy of the origin key and the unmasked key, means origin key and masked key are obviously the same. The entropy jumps slightly for the masked key. Entropy was measured using the Shannon's algorithm for AES, for RSA, and you can see since RSA is most secure out of the three cases we have discussed. For RSA, the entropy is highest. For DES, which is the simplest, entropy is lowest, and for AES, it is in between RSA and DES. However, you can see that for each of the three cases, wherever we have used the masking technique, the entropy rises for the transpirator key, indicating more randomness and more anonymity, I would say, in a certain sense. These are the actual figures you can see here for DES. Original key is 3.65, mask. These are the same keys, so it will be same. The entropy is elevated for the masker key, and then its effective key to some conclusion is given. It has some resilience. We have not done that attack thing we intend to do it in future, and some limitations are there could be some performance overhead, though it is slight. You could have dependency on hardware, and if the random seed is leaker, there could be a certain problem. And future scope you would have, we would like to have real world testing, optimization on resource constrained devices, and dynamic range parameter adaptation. We would like to expand the pre-shared or the random seed. These are the references. That's all, and thank you very much. Yes, please.
Yes, sir.
Yes, please.
Sir, your technique, it can be adapted for use in post-quantum cryptography? Or like
We have
in
not done the study, but like I said, if I have not done the study, we have not gone to quantum cryptography. That is a really emerging and interesting area. But in my humble opinion, what I think is that if quantum cryptography also uses a key, though it uses properties like entanglement. I am myself a student of quantum computing. It's a vast and very fascinating area. But if somehow there is a key for quantum cryptography, again the same technique can be applied to the key of the quantum cryptography also, though I'm not sure. In my opinion, I'm not sure about
but sir,
whether
in
to
future
use a key in
relevancy,
quantum cryptography or not. Ji, sir.
but in future relevancy, if you see that, then for the application of emerging technologies, thereafter we will have to use that technology, right?
Yes, obviously.
That's why I'm asking, is it capable to continue with that?
See, right now, sir, quantum cryptography might be interesting and fascinating, but to replace the whole global infrastructure with quantum cryptography will take some time. Till then, I think we are safe with some minor changes like this, and who knows, maybe it finds a good place for quantum cryptography also. We will have to see what type of actual implementations of the quantum cryptography algorithm are done in real-time space. Yes, sir.
One more thing, sir.
Hmm.
How
Yes, sir.
your augmentation will compare with the technique like key schedule strengthening or S-box randomization like that? Will you
We
elaborate?
have not done that extensive study. This is a very preliminary study, and it is in the
Okay,
process of infancy right now. We have not done that much study, sir.
okay, sir. Thank you then.
Thank you very much. Thank you. Can I leave? I have some work. Can I leave, sir?
Sir, just a minute. Priyadarshini ma'am, do you have any questions?
No, not from me, sir.
Okay. Dr. Hafiz, you can, yes, if you have some urgent work, you can leave the meeting, but we were going to announce certification related details at the end of the meeting.
Okay. Thank you very much. Thank you.
Yeah.
Bye-bye.
So we'll move towards our next presentation. Uh, Mr. Sanjay, are you ready with your presentation? Okay. Just a minute. Yeah. Ms. Shipra, are you ready with your presentation? Hello. Am I audible? Can someone just confirm that am I audible?
Yes, you are audible.
Okay. Shipra Agrawal. Okay, we'll move towards next. Mr. Begwenwan, are you ready with your presentation?
Yes, I'm here. I can read it.
Okay, sir. You may share your screen and start your presentation.
Yeah. Have you all seen my screen? Sorry.
Yes, sir. We are able to see your screen.
Yeah, thank you. Good afternoon, everyone. My name is Nguyễn Quang Bảy from Ho Chi Minh City Open University, Vietnam. And today I'm honored to be presenting our work Thai Sumin end-to-end transformer model for image to latex with enhanced performance and large data sets. So the today presentation will be discussed about our model for the task of extracting math formula from images include 5 parts as well. And I will go quickly to our works after a short overview. So we will discuss the importance of the mathematical formulas in fields like science, technology, and academic publishing. These formulas are essential, but creating and formatting them can be a challenge, especially when dealing with images. This is where the the image to latex system comes in. It converts math formula from images to latex sequence and making it much easier to integrate formulas into documents. Whether you are a scientist, educator, or general users, image to latex simplifies the process and saves times. In short, image to latex is a powerful tool that makes working with mathematical formula much more accessible. But now, let's discuss the limitation and the existing system. The NFT system works well with basic mathematical formulas, but is struggling with more complex structures. Recognizing math formula isn't just about identifying characters, it also requires understanding the structure of the formulas. Recent advances in encoder-decoder architectures have improved this process. These models can handle the entire recognition process, from feature extraction to generate the output, on in one step. Previous systems mainly focused on either printed or handwritten math formula, but these new models are designed to tackle both. In summary, while current systems have their limitations, recent advances are pushing the boundaries, making math formula recognition more efficient and accurate. So we developed a large-scale dataset to improve mathematical formula recognition, enhancing model accuracy and efficiency. Additionally, the Suman model, our model, achieves superior performance in both printed and handwritten math formula recognition, marking a significant advancement in the field. So we go through this. Key models is encoder-decoder architectures, include the Tencent-based model by Yunqian Teng et al., which combines CNN and an RNN decoder with Tencent, and the neural transducer by Smith Sings, which adds visual attention and beam search for better inference. Yun Wang and Jin Chang Liu introduced a model using CNN and partial encoding with an LSTM long system memory decoder to generate latex. Mingo Chou et al.'s transformer-based model used the VIT VIT encoder and YOLO-based preprocessing to improve accuracy by distinguishing single-line and multi-line formulas. And the birational and the Tencent refined model include BTTR and by Wenwei Chao et al. And IBM by Hang Bian et al., which use birational training with an RNN decoder to reduce coverage gaps between, increase the computation. The math expression recognition by Peng-Phi Chao and Lin-Kai Gao as the attention refinement module, enhancing feature alignment and boosting transformer performance in handwritten math formula recognition. And here is how our architecture works. The screen transformer combines the CNN's hierarchy with attention mechanism using window-based cell attention and shifted windows for efficiency feature extraction. It processes image from the height, weight, and we multiply with 3 dimensions, right? into key value features, KV feature vectors, and enhancing the scalability and representation. The decoder transformer is an auto-recursive language model that generates LaTeX sequentially left to right. Using cross-multi-head attention, it processes K-value features vector from the encoder to produce LaTeX representation of the input math-formular image. So here our dataset consists of two domains, as we mentioned in the previous slide: handwritten math formula and printed one. We are created a separate dataset for each with a total of 3.5 million image text pairs. It includes over 200,000 handwritten pairs and 3.23 million printed pairs. So here is the results when we apply our model. Let's look at the results of handwritten mathematical formulas. And so in the image, we evaluate our model using datasets like from, IDA, and the handwritten math formula convert to LaTeX datasets are available on the public. And our model successfully extracted the formula into LaTeX, demonstrate its capability to handle complex handwritten math formula content. As you can see here, here's a picture of the math formula, and then we will extract into LaTeX format. That's the previous one in the handwritten, and here is the printed one. So moving on the results of the printed mathematical formulas, we test our model on several datasets, include image to LaTeX, 100K, and many others. The model demonstrates impressive performance, successful extract printed formula into LaTeX across the diverse datasets. You can hear. And here is the performance comparison on image to LaTeX 100K test datasets. We evaluate our model on the printed math
Excuse me,
formula.
Mr. Bay.
Yeah.
So you have 2 minutes of time left to conclude your presentation.
Yeah, thank you for that. We evaluate our model on the printed math expression recognition task using the image to LaTeX 100K datasets containing 100,000 real-world math formula from ICTIS.org with over 10,000 test samples. Using metrics like low score, exact smart, and edit distance. The results in the figure, so our model outperform others in low score and edit distance, indicating high quality sequence generation through the exact match score in model array. As you can see here in the final column is our model performance. And here we use the chrono test from the competition about the handwriting math formula. It's very popular. We evaluating, and you can see that in the figure, our model outperform other, achieving the highest score on 4 accept rate metrics for from 2016 and 2019 up to 95.59%. For the Chrome 2014, it performed best on Type 3 era, highlighting the robustness and effectiveness of our approach. And in conclusion, our key contribution included unified framework that handles both printed and handwritten math formula. We also developed a large-scale dataset that significantly improved image to LaTeX accuracy. Our model had achieved state-of-the-art results on benchmark datasets such as from 2016, 2019, and image to LaTeX 100K, showcasing its effectiveness in formula recognition. And looking ahead, our future work will focus on expanding the handwritten math datasets. As you can see at the figures, we just have over 200,000 datasets of the handwritten, and altogether to improve generalization across diverse styles. We also plan to explore the use of generative adversary GANs, to generate synthetic handwritten math formula, having balanced the datasets and further extend model performance. And that's the end of my presentation, and thank you for listening. I appreciate your time and attention, and I'm now ready to answer the questions you may have.
Okay.
Yes, yes, ma'am. You continue, please.
Okay. You have used GAN, right?
Well, we use the transformer model, and again, it's in the future we will try
Okay.
to
Were
use that.
you able to differentiate between original image and GAN generated images?
Sorry. In the
Using
previous, you can
GAN,
see that.
yes, using GAN, you would have created images, right? Handwriting images. Are you following me?
Yeah. I'm following. But actually,
Yes.
just
So have you found differentiation between original images and GAN generated images?
well, actually, we focus on the images from text document, also like printed document, and then we just take a picture, and then we'll represent the image and extract the text. I mean, in this particularly situation, we will extract the math formula into LaTeX format. Yeah. So the images is just like the input. We are widely collect from online and both offline. Yeah, online document and also offline documents.
Okay, maybe I think you have not segregated, but in future, that this is also a trending topic right now. Applying GAN is fine, but differentiating between GAN images and the original images, whether you are able to segregate them, you can check. Okay.
Yeah, thank you for your suggestion.
Yes. And taking handwriting is really a good thing, especially for Max. I'm really wondering if for a bad handwriting, how will your model work?
Even the model, our model works, right? So as you can see here, is extract from the
Yeah, this is a
image
nice
into LaTeX.
handwriting here. I am
Yeah,
talking about really a bad handwriting.
Yeah.
That's all from my side. Sir, you can go ahead.
Yes, thank you.
Okay, yes, I have a question. Have you evaluated the latency and inference speed of your model? I mean to say, can it be used in the real-time applications such as OCR plugins for scientific journals like that?
Oh, well, actually, we are now enhance the accuracy, and previously we are just using the transformer OCR, the combining of the transformer and the optical character recognition technique in the traditional, and we have been doing a simple application for testing. But
It
actually
can be
now
used
we
for the real time, right?
well we just pay more attention to the accuracy to enhance the accuracy in this paper. Yeah.
Okay.
Yeah, thank you.
Okay, then thank you.
Thank you for the question and consideration.
Okay, thank you, Mr. Bai. Now, we'd like to move forward with our next presentations. Our next presenter, Shipra Agarwal, who will present a paper on recent trends in cryptographic techniques for securing ZigBee IoT devices.
Good afternoon, sir.
Good afternoon, ma'am.
So, I am audible?
Yes, ma'am, you are audible. You may share your screen and begin.
Yes, sir. So, whether my screen is visible to you?
Yes, ma'am, your screen is visible.
Okay, sir. Good afternoon to everyone. Wait a minute. My topic, I am Shipra Agrawal from Guru Ghasidas Vishwavidyalaya. My paper ID is 90 and my topic name is Recent Trends in Cryptography Technique for Securing IoT Devices. Here is the list of contents that I will be covering: introduction, literature review, discussion, ZigBee architecture and protocol stack, security issues in ZigBee network, conclusion and references. First,
Excuse me, ma'am.
introduction. Hello, yes, sir.
Ma'am, it seems your PPT is stuck on the first slide, the introductory title slide. Can you just move it in slideshow mode so we'll able to see
Then it
the
is in
slides
slideshow
changing?
mode. Sir,
No, it's not visible to us.
okay, sir. Let me share it again.
Yeah.
Sir, now is it visible?
Ma'am, the screen is visible, but not yet in the slideshow mode.
Okay, sir. But I'm presenting in slideshow mode only.
Can you just leave your slideshow mode on your device?
Sir, now is it visible?
Yeah. Now we are able to see the changes in slide.
Yes, sir. Sir, as with the rapid development of Internet of Things, by entrenching intelligence in everyday objects like sensors, actuators, and controllers in various applications such as healthcare, smart homes, and industrial automation, one of the widely used IoT network is ZigBee. This is favored for its cost effectiveness, low power consumption, capability, and scalability. They are often organized in environment where data integrity and authentication play a vital role. But due to its constrained nature, some traditional cryptography method is difficult to implement due to its high power, substantial bandwidth, and large memory storage. Thus, there is a need for lightweight cryptographic algorithm for constrained devices. So these are the papers that I have read for the survey. First paper that I have read of 2018, whose entitle is Security Algorithm of IoT-based ZigBee Protocol. It uses AES 128. Its performance is better in terms of speed and complexity, but secure key storage and distribution is complex. Second is of 2019, whose entitled Enhanced Timestamp Screen for Mediating Reply Attack in Secure ZigBee Network. It uses AES in CCM mode with for maintaining low power consumption and blocking reply attack. It reduces power consumption and network traffic, but it dependent in clock synchronization, dependent on clock synchronization. If clock synchronization fails, it leads to denial of service attack. And so on. These are the 15 papers that I have taken for the survey. After this, the main objective of my research is to evaluate the effect of encryption and decryption process on the overall performance of ZigBee, particularly in terms of data transmission speed, and to find an energy efficient encryption protocol that will transfer the data securely, but with maintaining low power consumption to provide robust security in ZigBee. This is the ZigBee protocol stack architecture. First is physical layer. This layer is responsible for transmitting data with radio waves. Mainly ZigBee functions with the bandwidth of 2.4 gigahertz industrial, scientific, and medical band. But in Europe, it works in 950 megahertz frequency, and in Europe, it works with 868 megahertz. Media access control. Second layer is media access control. It allows transfer of MAC frame through physical channel, and its main objective is to avoid avoid collision during the transmission of the frame. Third layer is the network layer, whose main responsibility is routing to maintain continuous communication across the devices. Fifth layer is the application layer, which is user interface layer, which enable communication between the user and the system. 6th layer is the network layer, whose main responsibility is to routing to maintain continuous communication across the devices. Fifth layer is the application layer, which provide which enable communication between the users, the user and the system. 7th layer is the application layer, which provide Fourth is then comes the network security architecture. This architecture provides the security to the ZigBee. It mainly supports the integrity, access control, confidentiality, and authentication. There is a central unit which is selected as a trust center, which manages the device. So, the device security strategies, authentication, and key distribution within the network. Then comes security key management. ZigBee includes wide range of key management. One key is the master key, which maintains that only authorized user can communicate within the network. Then comes the network key, which is the 128-bit key, which enables the encryption of general communication. Then at last comes the link key, which is also a 128-bit key, which is used to pair the devices. Then comes the component of the ZigBee architecture. Application support. There are four components. Application support layer that provide access to specific services. Then network layer that it provides security at the network layer using network key. Then trust center, it provide a securely distribution of key within the network. Then access control layer provide which devices are authorized to communicate communication. This is the structure of the ZigBee network. ZigBee basically provides security to the application layer and network layer. Also, sometimes it also provides security to the MAC layer, but this security is basically carried out by IEEE 802.15.4 standard. These are the security issues. Reply attack. Reply attack is basically the attack in which the attacker acts as an authorized user, and interrupt the performance and messages. And this attack is common in ZigBee. And then comes key management vulnerability. This to maintain cryptographic key and distribution is a complex task. So because as a randomness while transferring the message, there should be proper randomness in the messages so that it does not get manipulated by the attacker. This is a complex task in ZigBee. Then physical and side channel attacks. This two types of attack basically exploit the physical properties of the devices to find the delicate information from the delicate information. This pose us exception dangers in the ZigBee devices. Then weakness in authentication mechanism. Sometimes it happens that a trust center coincide or when ZigBee switches from one devices to another. At that time, there is a chances that authentication mechanism get weakened. So in order to maintain the authenticity overall the transfer of the messages, it is a crucial task to provide a cryptographic method that will maintain authenticity throughout the network. Energy depletion attacks. Sometimes attackers pose attacks which mainly affect the battery life of the ZigBee by increasing its by draining its battery rapidly. Which reduces the durability of the devices. So in order to protect, to enhance the durability of the devices, it is necessary to provide an algorithm which will maintain the battery life throughout the transmission of the data. This is the pie chart which shows the performance of the ZigBee in terms of cryptographic algorithms like speed and complexity, attack, successful alert generation, lightweight, energy friendly, and low power and traffic. Among this shows that this is nearly 20% in all the cases. Then conclusion. This
Excuse me, ma'am.
Yes, ma'am. Yes, sir.
Ma'am, sorry to interrupt you, but you have got 1 minute of time left to move towards the conclusion.
Yes, sir. This review offered this review shows a complete exploration of the difficulties and the development in the ZigBee to maintain the performance and security into the IoT devices. This review shows that the comprehensive security in ZigBee network by maintaining a energy efficiency in to operate in resource constrained environment, and also highlight the need of lightweight cryptographic algorithm to transfer the message securely with low power consumption. Future research will bring out some more lightweight advanced cryptographic method that will securely transfer the data with low power. These are the references. Thank you, sir.
Yes, madam.
Yes, sir.
I have a simple question like you. Is it enabling ZigBee devices with dynamically switch between cryptographic protocol based on the risk level?
Yes, sir. Actually, sometimes, according to my study, there is only what I do. Only one algorithm, like for symmetric algorithm like AES, and for asymmetric RSA algorithm, ECC algorithm is only transferring data. Using ZigBee is basically communication protocol. So using ZigBee, only this type of algorithm is only transmitting data using ZigBee. So I think which is when I was studying my papers, I have seen that the AES is consuming 100 milliwatt of power. So
you have not mentioned about that how cryptographic protocol will based on the risk level. That's why I'm asking.
Cryptographic protocol is based on risk level. Sir, I think so. Risk level is that when we are transmitting data, that time if attacker exploit the data, then it may affect the battery life of ZigBee, which will affect the performance of ZigBee and may also damage the devices. So in order to maintain that secure, cryptographic algorithm should be brought, I guess. More secure algorithm with low power consumption should be brought.
Okay.
Priyadarshini ma'am, do you have any question?
No, not much. Can get.
Okay. So all the presentations for the session are over. So now I declare that session 10A has concluded, and I sincerely thank our authors for the excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 9th version and all the previous 8 versions of the conference. We will be happy to have you in the 10th version in 2026. All the presenters would be getting the digital certificate through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICTIS 2025. I also thank our session chairs for chairing the session. This is a token of appreciation to the chairs on behalf of Team ICTIS 2025 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence. I kindly request you all to switch on the camera for a quick snapshot of the virtual conference. All the authors present in the meeting are requested to turn on their cameras. Thank you all. Stay safe and take care.